Okay, sorry guys, because every time I do this, it has to crash once and then I have to restart the program and then do it again. So sorry about that. All right, so again, so we have this here, and if you're, all right, thanks. We have this video here for you. You can go back to it and pause it whenever you need and then copy this stuff. But what you're going to do is you're going to factor each denominator first. So that's what we're going to do here for this first problem. And you can see this denominator, this is actually factored, but this is not and this is not. So we're going to have to factor those. So let's do that. Okay, factor first. So I'm going to rewrite this, but I'm going to factor the ones that can be factored. And so that's not the numerator, the denominator. Okay, plus 1 over v plus 1. So the red is what I did to factor, okay? So I should say factor first. Exclamation. Okay. And at this time now, we need to find our common denominator, and now our common denominator is going to have factors in it that are more than just a monomial, meaning like a one-term thing, but there's going to be a two-term thing in parentheses. And that's fine. Our common denominator is just going to have the v plus 1, and it's also going to have the v. So it's going to have this v plus 1, our CD. Our common denominator is going to have to cancel a v, and it's going to have to cancel a v plus 1. So that's going to be our common denominator that we multiply on each term. Okay? Now, one way to think about this also is if we get the same denominator on each fraction, okay, then we can just get rid of the denominator, which is kind of what I wanted to show you today. What am I talking about? Well, you look at them and you go, well, I've got a v times a v plus 1, v times v plus 1, but this one, what is it missing? A v. So I need to multiply a v on top and bottom. It's way over there, whatever. Okay, so I need to multiply a v on top and bottom of that one to get it to look like this. Okay, but once I've done that, then I can simply get rid of my denominators, all of them, and then just look at the numerators. And this is kind of nice, actually, if you ask me. Just get rid of all those and then rewrite what I have on top. Okay? Because everything's over the same thing, therefore I can just write what I have there. Okay, so but you need to just understand that my common denominator is that. So now it's pretty easy to solve, right? So I just take away 2v from both sides. I got negative v equals, and then negative 2 plus 1 is negative 1. So negative v equals negative 1. Therefore, just divide both sides by negative 1. And then v equals 1. All right. So the name of the game today is to just get all the denominators to be the same and then get rid of them. Okay? So it's a little different maybe from yesterday, but it's really the same exact concept. All right, so that's that. Maybe you'll like this method more. You can use it. Oh boy. Okay. Our second problem for the day is going to be this. Plus 1 over, and because I haven't taught you really that, I'm going to have to change it real quick in my head. So plus 3. Okay, so that's your denominator for that one. Equals 3 over p minus 2 minus 2 over, and it's going to be p squared plus p minus 6. Okay. So, again, factor first. So, we need to factor this, and we need to factor this, because those are not factored. What do? We've got this thing here, and it's -6, so what two numbers multiply to -6 and then subtract to 1? Yeah, so 2 and 3. So 2 and 3, they subtract to 1, but this here is +1, so we're going to need to get that 2 negative and that 3 positive. Okay, so +3, -2, that'll get us the +1 when we add them, and that'll get us the -6 when we multiply them. So that's how they're going to factor. So I will do that, factor this. P minus 2 times P plus 3 equals 3 over P minus 2 minus 2 over P minus 2 times P plus 3, because it's the same thing. Okay, so this right here is now what we have, and this up here goes with the other problem, so don't confuse it. Now, you look at all the denominators, and you see, okay, well, I've got a factor of P minus 2, I've got a P plus 3, and that's all I got. So these both have both of them, but which one is this missing? Yeah, it's missing the P plus 3. So I'm going to have to multiply that on top and bottom, so that the denominator is common. All right? So you just get all the denominators to be the same. Once the denominators are the same, all you have to do, scratch that out. Yeah. And then just look at the numerators. P plus 1 equals 3 times P plus 3 minus 2. And then you got to solve this equation. So P plus 1 equals, and then you got to distribute the 3. That's going to be 3P plus 9 minus 2. So you take that negative 3P. 9 minus 2 is 7, so that's 7. 3P plus 7. Oops. Yep. 3P plus 7. And then P plus 1 on this side equals, so I like the numbers to the right and the letters to the left. So I'm going to go minus 1 here, minus 1, and then minus 3P, minus 3P. And I'm going to transfer this up here because I just ran out of room on my paper. But this is going to be canceling, that's going to be canceling. And I've got negative 2P equals 6. So, and then I finally divide my coefficient off, and then P equals negative 3. Okay. All right. Now, here's a problem with this, and this is why I wanted to show you this, this question. When you're done with all of these rational equations, okay, something that you have to do is you need to check for solutions that are what are called extraneous solutions. Okay, so my solution here is p equals 3. But what I need to do is I need to check that and make sure that if I plug this in to the original problem up here, that it doesn't give me a 0 in my denominator. Okay, so that's called, if it does, then that's called an extraneous solution. All right, and then really, I mean, in this case, I mean, there wouldn't be a solution. Okay, so then let's see if that is the case. Well, I can see that it does actually look like it's the case. So if I take -3 and I plug it in here to this denominator, this is going to be 0. So if I have 0 in my denominator, let's see, if I plug it in here, that's definitely going to give me 0, you see. So all I did is factor that. But you got to check that. So, oops. Trying to get this right here. So I'm going to just continue, or try to continue here. But if I continue on the next page here, what I want to do is check to make sure the solution doesn't give you 0 in the denominator of the original problem. Okay, so you got to check to make sure the solution of -3 doesn't give you a 0 in the denominator of the original problem. So the denominator of the original problem was up here, okay, over here. So here, here, or here. So any of these denominators, if you take -3 and you plug it in for p, is this going to be 0? Is this 0 or is this 0? And if that is the case, then what you have is called an extraneous solution, okay? If you get 0 in the denominator, then the solution is called extraneous and doesn't work. So if I get two solutions for my answer, meaning like if I solve a quadratic and I get like p equals -3 and p equals 5, I've got to try both of them in here and see if they both work. If one of them does not work, like in this case -3, it actually doesn't work because it produces 0 in the denominator, then that means this actually has no solution. Okay, so there's no solution to this. So what you're going to do is you're going to go back to your solution, you're going to cross it out, and you're just going to say, well, there is no other possible answer, so this problem actually has no solution.